Good afternoon, or good morning if you're joining us from the West Coast. This is Victoria Beal with the Ohio LTAP Center, and I am so pleased to have my colleague Bruce Drews with us today for the fourth part of the Gravel Roads Design and Maintenance webinar series that we've been offering. We are happy to have you here. You've made it to the last section. Good for you. And you're going to have some great information today on dust control for gravel roads, unpaved roads. So you guys probably know the drill by now, but if you wouldn't mind, housekeeping wise, go ahead and drop me a hi or hello in the question box, just so I know that you've seen it and you know where it's at, because that's where we'll be accepting questions from. And for those of you who might be joining us for the first time, I don't know, maybe there is somebody on here who's just catching this section of it. And as a reminder for everybody who's been on here for the others, in the handout section, I do have a copy for you of Bruce's slides for today. It's the online unpaved road stabilizers file. I've also put in there a copy of the document you're seeing on your screen currently, which is the Unpaved Road Dust Management Guide from Federal Highway. And I put in some flyers for upcoming webinars that we're going to be hosting in case you might be interested. We've got a restricted crossing U-turn that Mark Doctor is going to be offering for us. We have self-evaluation transition plans and ProAg that Ron Eck, who is the former director of the West Virginia LTAP, will be offering. And then Ron's also going to be offering a tort liability and risk management. That one's not till August though, so if you're interested, hopefully you can work it in your schedule. The other thing I want to mention before I turn things over to Bruce is that there is a gravel road design and maintenance manual that is available, and we used to have paper copies in our office, but like everything these days, it's gone virtual. So when I send the follow-up email out to everyone, I will also be sending out a link to where you can find a PDF of that current manual, so you can have it as a resource to go along with the information you've learned here. I believe that's all I've got, Bruce. Are you ready?
Yes, I am, Victoria.
All yours.
All right, thank you very much. And again, welcome to this gravel unpaved roads and maintenance design program. And like Victoria had mentioned, this is the fourth of the four-part series. And today we're going to be talking about stabilizers, dust palliatives and gravel road stabilizers. But before I get going, this unpaved road dust management guide that you have before you, I have this up for one simple reason, and it's because I love this picture that I have on the screen right now. This is actually up in northern Idaho, outside of Coeur d'Alene, and the road is called the Ohio Match Road. So it's very applicable to our program today. But this Ohio Match Road, it's a unpaved roadway, still is. It's running about 1,500 vehicles a day. So fairly high traffic for an unpaved roadway, but by the same token, it goes up there about another 6-7 miles, and then it dead ends out in the middle of the forest. And so it's not really a through road. But the reason I like this picture is, and I'll bring you in just a little bit closer in the picture, is that if you notice, this roadway, we spent quite a bit of time and effort on this roadway up in the Lakes Highway District in Coeur d'Alene. We actually had a vendor come in and talk to us and suggest a stabilizer on it. And he came in and actually installed some stabilizer just below this house. And we had a major failure. The material did not work. As a matter of fact, it failed so miserably that you could pretty much take a shovel and take the shovel handle and shove it down into the grade of the roadway. It would not compact. And so we ended up having to come in and do a lot of work to reshape this roadway and rebuild this roadway. Currently, that roadway, like I said, is about 1,500 vehicles a day. It is graded once in the spring and once in the fall. In the spring application, they actually come in and do another light treatment of magnesium chloride on it. And then in the fall, they pretty much just water it and then regrade it and recompact it. But the amazing part of it is if you take a look at that house, back behind that house, you see a clothesline with clothes on it. That was that treatment. Once we had done that treatment, that individual that lived in that house was finally able to hang their clothes out on the line. She said that beforehand, before the treatment was done, the clothes would come in just about as dirty as they went into the wash machine if she hung them outside, so she had to use her dryer all the time. And so she was really excited about being able to use her wash machine and then hang them out on the line. So that's kind of the reason I like that picture so much. But let's go ahead and move into the presentation. And let's come back up. And so, of course, like I've done on all the others, of course, my name is Bruce Drews, and I'm a consultant that travels around, and I do trainings on gravel road stabilization, winter maintenance, works on traffic control, a number of other courses all over the United States. And if most of you have been through all three of these, and you know that I come from Boise, Idaho. That's where I'm at right now, and that I've been in the maintenance construction area for about 40 years in the transportation organization. Retired in 2013. I also always acknowledged David Jones. Him and I worked and developed this presentation, and we've actually done quite a bit of training together on a number of different gravel roads projects. Today, what we're going to do is we're going to take a look at some of the families of the stabilizers or the dust palliatives, or, I call them stabilizers because the goal of it is to stabilize that roadway, hold that binder that you put in that roadway, so you hold it in place and keep it from moving, which then helps hold the road together. And then we'll also talk a little bit about that installation and that maintenance of those stabilizers, because depending upon the type of stabilizer you're going to use determines what type of maintenance you're going to be able to do on that road, or how often you may end up doing some maintenance on that roadway. And so we'll talk about some of those items as we take and go throughout this program. Before I get going, though, I would like to talk to you a little bit about a project that I had when I was at the Idaho Local Technical Assistance Program. We got together, and in Idaho, we have about 45, almost 50,000 miles of roadway. The Idaho Transportation Department maintains about 27,000 miles of roadway, and they're all paved, except for they have about 20 miles that are unpaved. They're gravel, and will be gravel for probably the rest of eternity. But then the local jurisdictions, they have another almost 40,000 miles of roadway, and almost 75% of those roadways are gravel or unpaved. And so what we did is, as the LTAP director, we worked with the agencies to take and look at developing a transportation management plan, because most agencies have some pavements, they have some gravel, they also have some roadways that have no gravel on them at all. They're dirt. And they're usually really low mileage. And so what we did is we worked with the local jurisdictions to develop that transportation management plan of saying, okay, these are our major corridors that we have a lot of traffic on. These are our intermediate corridors that we have moderate traffic on. And these are our low volume corridors, our very low volume corridors. Because we have, quite frankly, we have a few roadways that might see one vehicle a week or one vehicle a month on it. But by the same token, so we looked at all those different corridors and then established kind of some priorities on how to manage each of those corridors, because they're not all managed the same. There's some corridors that you maybe go take a look at every once a year or twice a year, and then some other roadways that you're out there on that roadway almost every day. And so we establish kind of priorities. Then the other thing that we took a look at is of all those unpaved roadways, because some of the local jurisdictions here in Idaho, they use what they call a free material. It's a material they just come in and load it up into the truck out of the bank and take it out onto the roadway, and that's pretty much what they dump out on the roadway. The only problem is you don't know what your gradation is. You don't know how much binder you have in it, and it changes depending upon what part of the pit you're getting it out of. And like I mentioned in part 1 of the series, anytime you touch anything, you have cost in it. You have labor costs, which labor costs are very high. You have equipment costs because you're moving material with equipment, with a loader, with a truck, those types of things. All those costs impact your organization. And then the labor part of it is that if your people can make mistakes and cost you a lot more money, either through mishandling a material or taking and making a mistake. I had one agency that they had a gentleman that thought, oh, shoot, I'll be Mr. Nice Guy and I'll grade a couple of these driveways off of the roadway to help these people out. Well, then all of a sudden they're in a lawsuit because they got a new grader operator out there and he wasn't going to grade those driveways. And so people complained, and then they finally took the organization to court and said, hey, you used to do it. Why aren't you continuing to do it? So that's some of the training and some of the education that we needed to do. We also took and came in, and I brought in some subject matter experts. We brought in David Jones and Ken Scorseth and Steve Munlocks, and we actually brought in a supplier of magnesium chloride, and we'd have a workshop where we'd invite all the local jurisdictions in this area. They'd come into this workshop, we'd select a road, and then we'd spend one day doing a training and teaching them about gravel road materials, about how to take and deal with it, about stabilizers and all the other information about it. And then the next day, we'd actually go out and grade that gravel roadway. We'd have the operator of the jurisdiction that owned that roadway grade it, but then we'd show them how to take and check their slope, make sure they got the right crown in it, make sure that they're taking and have enough water in it. And then towards the latter part of the day, we'd actually come in and put some stabilizer on it, usually a mag chloride type of stabilizer. And we'd take and do about 3 of these workshops a year in different locations around the state. We had this program for about 3-4 years. And that's the reason I say most of the local jurisdictions here in Idaho, on their most heavily used unpaved roadways, they use stabilizers. So I want to check, and I've got a survey question, is of those organizations that have used chemicals for stabilization or dust control, how have you used them? A, used on spot locations in front of houses and buildings, used on specific road segments, have been thinking about using a chemical, or have used an auto seal or some other type of a seal. I used to always call them a BST, a bituminous seal on some of those unpaved roadways.
And that poll is currently running, Bruce, so they are responding. And as soon as we get a higher level response, which seems to be ticking up pretty quick here, I'll close it out and share the results with everybody.
Excellent.
So far, we've got responses in every one of those, so that's very interesting. Yeah, I can sympathize with that lady with the clothesline at the very beginning. I used to hang clothes out when I was younger, and boy, nothing would make me crazier than to have a big truck go down the road and kick all the dust up.
Well, it's very interesting. The road superintendent, and this picture you're looking at right now is actually up in that same area, up in the Lakes Highway District. In his 35 years with the Lakes Highway District, he said that he used 6 gravel pits, totally used up 6 gravel pits, and he said he needed to do something because if you walk out into the timber or out into the grass, he said the dust was so thick on the trees and on the grass
Mm-hmm.
because they weren't doing anything, that it was causing an environmental hazard. And
Wow,
so he started getting into treatments.
that's good because we definitely don't need any more environmental hazards than what we already have out there. So
Yes.
I closed that poll down and shared the results. We have 16% of the audience that used them on spot locations. We have 51% that used it on specific road segments. We have 30% that have been thinking about using it, and 3% chose the auto seal option. So,
Okay.
and then there was a person in the question box that mentioned that that they do use them on their gravel roads as well.
Okay.
Okay, I'll close that poll down so they can see your slides again.
Okay. Excellent.
There we go.
Excellent. So, some of the things you need to think about, you know, you need to consider, if you're thinking about stabilizers or dust suppressants. Now, I know in a lot of local jurisdictions that, they maybe have somebody that complains about the dust in front of their house or in front of their barn or in front of their business, and so they decide or they talk to the local jurisdictions about using a dust suppressant, something to keep that dust down. And I personally don't like the terminology of dust suppressant because the main thing that we want to take and keep into our roadway is that binder. I mean, we paid to have that binder put out onto that roadway by labor, by work, and by everything else. And that binder is very critical to be able to keep that road in place. And so what I prefer to take and actually look at doing is, using a stabilizer, which can be also used as a suppressant, but they're kind of an interchangeable item. But by the same token, to stabilize the roadway and reduce the dust. And the other part of it is how much of that dust you have to suppress. If it's out in front of somebody's house and they have their lawn, they want to hang their laundry out and they want to do those other things, um, they want you to take and suppress all the dust. Now, a stabilizer or a dust suppressant can do that, but by the same token, you may see some additional costs. You may have to apply it at a higher rate or a little more often or some of those things. But if you take a look at your overall road segment, you know, you can have, generally speaking, if you have an overall road segment that's out traveling out through the farm fields or around through the country, and it doesn't have a lot of houses along it, being able to reduce that dust is greatly appreciated by the traveling population as well as the people that live along the road. Totally getting rid of the dust. Some people, most of the time people will put up with a little bit of dust, but they want to try and keep it down as much as possible. So you need to have a goal. How much dust do you really have to get rid of? What's your objective of that material or that roadway? Now, if you're seeing an increase of traffic on that roadway, and so you're seeing an increase of dust being caused on that roadway, you want to take it and try to mitigate some of that, but you also need to take and have an expectation. what is your goal for that roadway? Now, like I said, up in northern Idaho, matter of fact, I've got a number of roadways here in Idaho that they use different types of chemicals, but by the same token, you know, generally speaking, on those types of roadways, they're only managing or regrading those roadways twice a year, once in the spring, once in the fall. And the people are happy about it because the roadway doesn't kick up a bunch of dust. The roadway feels comfortable to them because it's solid and it's easy to drive. And matter of fact, on some of the roadways, you take and you slam on the brakes, you leave rubber. You don't tear up the road because the roadway is that stable. And so you need to take a look at it. Now, one of the things I find with dust stabilizers, or I should say road stabilizers or dust suppressants, is there's a lot of different types. There's over 300 different name brands of product out there. And it's really been interesting over the 40 years I've been in this business. I've seen, it seems like every company that has a waste product says, hey, we can use it on the road. And so they come out and they talk to the local jurisdictions. I mean, we had a company here in Idaho that they make cheese and they have all this waste this way. And they thought, hey, there's some of the chemicals that would make a good stabilizer in that. Let's see if we can sell our whey. Well, it didn't work out real well. And then it made your roadway smell like milk. But it didn't bind together, didn't hold it together. And so economically, it was infeasible. There's some of the other ones, you can have some of the products that are feasible in one place work really well, but they're not very economical in another area because you have a different type of road material. The other thing you need to think about is the environmental. Some of these chemicals, like you get into the salts, the sodium chloride, the calcium chloride, the mag chloride, which we'll talk about here in a moment, you put them out onto a roadway, they are a salt. And the animals do like to come out and lick on that roadway sometimes. Matter of fact, up in Montana, they have a roadway there that they're actually using a mag chloride for a anti-icing chemical, and they found that the bighorn sheep were coming down onto the roadway, licking the road to get the salt off the road, and they had a lot of crashes with those bighorn sheep, and so they had to take and actually ban that type of material on that roadway. And then we also need to take a look at what's the effective life of that material, because the longer it can last, the more benefit we get out of it. Like the gentleman, the Forest Service down in Arkansas, I mean, they had applied a enzyme to their roadway, and they saw that that roadway was able to stay in serviceable condition for 30 years. That was an expensive product, but you spread it out over a 30-year period of time, and you saved a lot of money. And so you've got to take, and as you're taking a look at these different chemicals and different products and different ideas, and I'll be quite frank with you, I've been approached by a number of salesmen, and some of them will tell you, hey, this will work on everything. You need to get definition, trust but verify. Make sure that they know what they're talking about. Make sure that the product's going to work. And if they can't provide the documentation, then maybe you shouldn't be taking and buying that product. And a lot of products you need to have a specification for. Like when you buy your asphalt, to do your seal coats or do your otter seals or do your other types of asphalt applications, you should have a specification for that, and you should sample it, because I'll tell you what, once you shoot that asphalt on the roadway, it's changed and you can't test it. And how are you going to take and say, oh, well, the asphalt was bad? Well, you can't do that because you can't test it. So take a sample of it. The Ohio State DOT, they have a sampling techniques, sampling testing procedures. Use those testing procedures and sample whatever you buy, so you can take and make sure you're getting the product that you're supposed to be getting. So dust, like I said, dust is a real problem to the traveling population, to the people who live along the roadway, also to the road itself, because that dust is the binder. The one thing that's going to help hold that road together and going to keep those rocks and that sand from moving around is that binder. And if you let it blow away, then you're going to have to replace it. And like I'd mentioned before, in part one of this series, we talked a little bit about the testing that they did in Colorado, finding that one pickup running on an unpaved roadway, untreated roadway, will take and blow off almost a ton of material a year. That's a lot of material that you're just, you paid to have put out there. And if you lose it, then it's going to cost you to put it back. And so you've got to think about, what are some of those costs, some of those items. And so you got to take a look at how much dust you have and how can we get rid of it. Now, I talked about in the grading part of the course on Tuesday that, if you get a roadway and like this roadway here, you take a look at the wheel tracks and they have a good crust under that material. If I came in here and I graded this roadway and broke that crust up, I would take and create more dust, and I'd lose more of that binder, and then I would have more of the loose material. So in some situations where you get a good crust on your roadway, don't tear it up, especially if you don't have moisture to put it back down, mix it back together, and lay it back down like it should be. Look at it's going to be it's a gravel road. It's going to be a little bit, you're going to have some bumpiness to it, as long as it's not extreme and it's not unsafe. Sometimes you need to take and let those roads go. So like we talked about in the material section on actually it was a Thursday, a week from last week Thursday, we talked about the materials, and that the material that is your dust is that material that passes that number 200 sieve. That very material is going to bind that sand together, that's going to hold that rock together. Or in some cases, it could actually be your material as it breaks down. If you're using a material that has a high LA wear content, say, if you have a material that's in the 40-50% range of the LA wear, it's going to break down by the traffic traveling over it. And that's the reason I talked about, checking your material and finding out how hard it is. How well is it going to hold up? Because if the cars are going to break it down, they're going to cause problems with that roadway, and you're going to end up, maybe with more dust and more of those types of problems. But it's the particles that float in the air, as a vehicle travels down that roadway. Can be from the soil, can be from the rocks, and also, depending upon the plasticity index and how well is it holding together and how dry is the roadway and how dry the material, that dust will increase. Or if we came in and graded that roadway as a dry roadway, we broke that crust, we've now fluffed it up and enabled the cars and the vehicles to take and easily blow that material off the roadway, creating a problem for us. Some of the things that contribute to the dust, the vehicle speed. How fast are those vehicles going? And I know on some of those unpaved roadways, our vehicle speeds are very high. I mean, you're talking, a lot of them are posted at 45 miles an hour. Well, your vehicle speed might be 55, 60 miles an hour. You know, some of your higher speed roadways, you know, like here in Idaho, you know, if it's an unposted roadway, it's a 55 mile an hour roadway. We see, you know, 65, 75, 85 miles an hour down that roadway because we don't have a lot of law enforcement out there. And so people have a tendency to take and move right along. The number of wheels on those vehicles. You look at the deaths behind a semi-truck versus a car, and it's considerable. The gradation of the material. What type of material is it? What type of moisture is there? You know, you're very fortunate in Ohio that, you know, you have a lot of humidity. And so some of these chemical treatments that are hydroscopic, meaning that they pull water right out of the air, work very well in some of those higher humidity types of areas. You get into my part of the country where we have very low humidities, we'll generally see a increase in humidity during the nighttime, which then gives that roadway some moisture if it has a chemical treatment on it. So those are some of the things you need to think about. Compaction. How well is that roadway compacted? What type of binding do you have between the rock, the sand, and the binder? Do you have a good durable surface? Are you able to hold it together? And as that material breaks down and starts to take and fail, you start to lose some of your binder. And then as you lose more of that binder, you'll take and continue to have problems. So when we take a look at stabilizers, there's 5 generic families of stabilizers. 5 generic families. Water. Water is the oldest, and we'll talk about water here in just a moment. Then there's what they call water absorbing chemicals. Those are your salts, and we'll talk about those salts here in a little bit. Then of course there's organic, and under the organic area there's petroleum-based organics, and then there's non-petroleum based organics. Those items like fry oils, you know, the corn oils, the beet juice, a number of those other types of products, and we'll look in that more detail here in a little bit. Then there's also the electrochemical chemicals. Those are chemicals that they look at trying to change the charge of the aggregate or the binder to take and try and lock it together and hold it together. Those are the ones that, you know, you have your sulfonated oils or your enzymes or your other types of products. They're all in those electrochemical types of products. And then the final class that I have there is the synthetic polymer emulsions. You know, they're products that actually use a polymer to take and try and glue things together. And we'll talk about some of those different types of products and how to take and apply those types of products. And then the final item that I have there is actually an additive that, you know, in some parts here in the state of Idaho, we have a lot of basalt, a lot of lava rock. And in those areas that we have a lot of lava rock and not very much borrow, we actually take and quarry the lava rock and crush it. And then we have to add a clay additive to take and be able to bring the PI up on our roadway to try and hold our roadway together. And so these are the 6 areas that we're going to be talking about pretty much for the next hour, okay? So like I said, water. I mean, water has been used for centuries to take and try and increase that surface tension of that material, that tension so that binder and that sand and that rock is all stuck together and kind of holds it all set together. And as long as there's moisture there, you know, they'll take and they'll hold it and keep the the binder from floating off and having problems. Now, it's easy to apply. A lot of organizations have a water truck. As you're building a road and you're grading a roadway, getting that water, that material, that moisture down into that surface aids in your ability to be able to grade that material and be able to lay out that material, and then of course compact it. Water is a great tool to be used to help and aid in your compaction of your material. So water is something that's been used a lot, but by the same token, in some areas of our country, water is at a premium. It's very hard to get, very expensive. We end up taking and buying a lot of water. Sometimes if you pump it up out of a stream or out of somebody's private well or out of somebody's irrigation system, a lot of times those organizations will charge us for that water. And so it has a very definite cost. And so we can't keep applying it, because then we end up taking and it gets very expensive very quickly. Now, there's the 3 chlorides. I call them salts because that's pretty much what they are. The calcium chloride, the magnesium chloride, and the sodium chloride. Most of you, well, actually, let me ask a survey question right here. And it says, do you use one of the salts for winter maintenance? Either calcium chloride, sodium chloride, or magnesium chloride?
And they are voting. So,
oh, excellent.
Give them a second to vote there.
Also, by your voting, if you use a combination chemical, write that in the chat box if you would. If you
I'll
use
read
a
those off.
combination, one of these for, what's that?
Yeah. So I'll read those off if they put them in there.
Okay, that'd be excellent.
One person put sodium chloride in the box, so they must be having an issue with the poll. If you can't respond to the poll questions, it's usually because you're in full screen mode and you just have to escape out. I'm sorry, not exit, but escape out, and then you'll be able to answer the poll question. And someone else put calcium chloride in the response box. Okay, we've got a pretty good contingency of people who voted, so I'm gonna close this survey down and not survey, but poll question, and share the results. So we have 37% that chose calcium chloride, 37% chose sodium chloride, and 26% chose magnesium chloride. And then in the question box, we had someone put in that they do calcium chloride and salt brine. So, okay. All right, Bruce, I'm going to hide these results now and it's all yours again.
Okay, I appreciate that. I appreciate that. And that's actually some of what I talk about in my winter maintenance training, is the differences between the calcium chloride, the magnesium chloride, the sodium chloride. I know that I've dealt with an agency over in South Dakota that they actually use a combination of a calcium chloride with a magnesium chloride as a pre-wet. And it's very effective in getting rid of the ice, but by the same token, they do have a lot of issues because it also damages some of their newer concrete work that's along their roadway. And so their state DOT has taken and pretty much mandated that they can't use those chemicals in the first 2 years of that concrete life, because otherwise it starts to cause them to have spalling. But calcium chloride, magnesium chloride, and sodium chloride are probably the most common chemicals that are used across the United States for either winter maintenance activity or stabilization. And actually, it's very interesting is that in the West or in the Rocky Mountain states, our primary source of both sodium chloride and magnesium chloride is actually the Great Salt Lake. And I don't know if you've ever flown into the Great Salt Lake area, but as you fly over the Great Salt Lake, you'll notice on the south side of the lake, as well as the north side of the lake, there's some enormous evaporation ponds. And those evaporation ponds are actually owned by either Morton Salt Company or Compass Chemical are the two companies that own those big evaporation ponds. And what they do is on the south side of the lake, the salt content or the chemical content in the lake is the highest. So they take and they pump the water up into their evaporation ponds, and what they're primarily after in those southern evaporation ponds is potash. Potash is a very lucrative chemical, and so they're after the potash. And so they pretty much pump the material in there and let the potash fall out of the water. And once the potash falls out, then they'll pump that water out of those evaporation ponds, and they have an open water trench that runs underneath the Great Salt Lake, and they pump it down into that trench. And then on the north side of the lake, they pump the water out of the bottom of that trench and into their evaporation ponds on the north side of the lake. And they say that they lose less than 5% of their chemical as they pump it under the lake. It's a pretty interesting process. Well, then they pump it back up into the evaporation ponds on the north side of the lake, and the sodium chloride drops out. It evaporates enough water out of it to have the sodium chloride drop out. The product they have left is magnesium chloride, plus some other chemicals, strychnine, heavy metals, some other chemicals that they have to remove out of that magnesium chloride before they can sell it. And so then they take and they filter that magnesium chloride to try and get rid of those chemicals. And so then they can sell their sodium chloride and their magnesium chloride, and they both come out of the same facility. The magnesium chloride is a liquid chemical in most cases, because to get it into a solid type of chemical, you have to heat it, evaporate out some more of the water, get it to where it will actually drop out and be a solid. The sodium chloride will naturally do that with just a little bit of evaporation. So generally speaking, your sodium chloride you buy is rock salt. Now, a couple of things. On all three of these chemicals, you need a specification. Sodium chloride, when they pump the sodium chloride out of the Great Salt Lake, or they dig it up out of the ground, and they take and they run it through their crusher, and they make it into table salt, they make it into road salt, they make it into a lot of different products. And each one of these products will have a different gradation for it. I had one agency that they went down to Morton Salt Company, because Morton Salt Company said, hey, we've got a really good deal on sodium chloride. They went down, they picked it up, and come to find out it was table salt. They had a bunch of table salt that had been rejected. Well, they sold it to this one city. They came out, they hauled it back up to their city, they stockpiled it, and by the middle of the winter, their pile was gone. The salt was so fine that as they got a little bit of rain, it was breaking it down, and it was running out into their grass and out into the stream right next to them. And that created a major problem for them. So you've got to think about these chemicals. Make sure you have a specification. The DOT has specifications for every one of these chemicals, and you need to be aware of what those specifications say. What's the concentration? Like I said, magnesium chloride comes as a liquid. And if you take and have a magnesium chloride, normally it's around about a 32, maybe you'll get up to 33, 34% concentration of magnesium chloride versus the water. You need that magnesium chloride to make it work. If it's mostly water, it's not going to work as well. So you need to make sure you've got the right concentration to be able to work. Now, calcium chloride and magnesium chloride are really hydroscopic. And hydroscopic means that they'll take and actually love moisture. They'll pull moisture right out of the air. They pull moisture right out of your boots, right out of your leather gloves. Any of those types of things, they'll dry it out because they want that moisture. And they'll hold on to that moisture, and they bind with the clay in the roadway, the binder that's in the roadway. And so they keep that clay moist so that clay is able to hold on to that sand and that gravel. Okay. Calcium chloride is exothermic, meaning that when it turns into a liquid, it gets hot, it warms up, it gives off heat. Magnesium chloride, as it takes and dilutes down, it can get a little bit warm, but it's not quite as bad as calcium chloride. Sodium chloride, on the other hand, is not very hydroscopic and is not exothermic. Okay, so sodium chloride, I have a few agencies that use sodium chloride to take and stabilize roadways, but generally speaking, their salt content in the roadway is pretty high. They're actually getting I've got one agency that has a natural well that is a sodium chloride well that has some magnesium on it, and they use it right out of the ground. And it works well, but they have some issues in it. The thing about the salts can also be applied in the calcium chloride, and the sodium chloride can be applied as solids. So you can take and dump them into a sander, spread them out on the roadway, use a grater to mix them up, put a little water in with it to take and mix them all together, and they'll break down and they'll take and form into the roadway. Magnesium chloride is not. It's a liquid. You shoot it on the roadway. Okay. Now, with all three of these salts as a prep for that roadway has to be wet. If the surface is wet and the underlying material is dry, that magnesium, calcium, and sodium will only drop down into that roadway as deep as that moisture is. If they hit a dry layer, they'll stop. And that's as far as they'll go, as far as stabilizing. And ideally, you want to get that material down, an inch and a half, 2 inches maybe down into that material. So you need to make sure that you have moisture that's below that 2-inch level. So you may need to come in the day before. What I do with most of my work that I've done is we'll come in the day before, moisten that roadway up, keep that roadway damp, come in the next day, take and start grading it around, get it all shaped up, get our 4% crown in it, make sure that we do it. And then my preference, especially with the magnesium and the calcium, is to compact it. Compact that road surface using a vibratory roller, maybe a rock and roll behind the motor grader, but get it compacted so I don't have to keep running my equipment on it when I apply those chemicals. And then I apply those chemicals at 1/4 of a gallon per square yard or less. So it might take 2 or 3 treatments on that roadway to get it up to where I'm at about 1/2 gallon or 3/4 of a gallon a square yard. The reason I do that is because I personally don't like running my equipment through the magnesium and the sodium when it's wet on the surface. The other thing you need to take and think about when you're using magnesium, calcium, and sodium is that, like any other chemical, if it's used wrong or improperly, it can cause environmental damages. We had a project one year that we were doing up in North Idaho where we were using magnesium chloride. We'd shot our magnesium chloride on the roadway, and we had a thunderstorm come by. It rained on us before the magnesium chloride had sunk down into the gravel. It ran off into the ditch. Unfortunately, down in the bottom of the ditch was a root that belonged to a very large ponderosa tree about a quarter of a mile away. Killed the tree. And this is a tree that is probably 20 feet in circumference. So it was a pretty good sized tree. And the jurisdiction had to end up replacing that tree, which was pretty expensive. So you need to take and follow the proper procedures for installing any of these products. Some agencies like to take and, as a grade the gravel roadway or the unpaved roadway, they like to take and have the material all fluffed up and then apply their chemical on it and then compact it. If you do that, or if you run your grader through that calcium chloride, magnesium chloride, or that sodium chloride, you need to wash the material off of your piece of equipment. Otherwise, it will rust. It will cause you problems. The beauty about these salts is once you install them, they pretty much stay right there in the roadway. And you can rework that roadway with some water, and that chemical is still there. Generally, what I see in most agencies will do is if they're using one of these chemicals, they'll take and come in the fall of the year, they'll rework the roadway. Then that following spring, they'll rework the roadway again and then add a little more chemical and then compact it, and then it'll be good for most of the summer. So that's the salts. You're able to pretty easily rework those types of products. Or if, say, the roadway gets pretty rough, you can come in and put in some water on it, grade it, and lay it back down and compact it, and it'll go back to being pretty solid. In some real dry climates, you will actually saw some issues with the salts taking and breaking down a little bit. In those types of situations, I tell agencies, just take a water truck, drive it as fast as you can down the roadway and just spray a light coat of water on that material and it'll come right back and rejuvenate it. So, those types of products work out pretty well. Organics. In the organic area, like I said, we have petroleum products. We use asphalt emulsion, some modified asphalt emulsions, some cutbacks, some that they call a dust oil, which is usually like an SS1 that has been diluted a little extra with moisture to take and be able to take and hold everything together, get it to penetrate a little bit deeper. Generally speaking, those petroleum types of products are all of an asphalt type, whether it's a liquefied emulsion or actually a straight asphalt. And we use them in a lot of different ways. The only problem you'll see in them is if you use and mix them with your material. I've seen some agencies, they'll take and come in with a grinder and mix in this like high float type of asphalt, some sort of emulsified asphalt, and they'll mix it in with their gravel and then lay it back down, and it'll bind together. But once it dries, it's there. Whatever you got is whatever you're going to have. You can't come back in, say 2 days later and take a grader and try and work it. So you've got to be very specific about how you're going to use it and how you're going to get it to hold together. And you need to make sure that it binds really well. Now, the non-petroleum products are really interesting because we're seeing a lot of newer ones, and we're also seeing some of the non-petroleum products being mixed with the salts, with the magnesium chloride, the calcium chloride, or the sodium chloride, like the lignin sulfate. The lignin sulfate is actually tree sap. It generally comes out of the most desirable tree is actually a lodgepole pine. And from what I've seen from some of the information, the most desirable is out of up in Canada, up in eastern part of Canada in the lodgepole pine forest up there. And it comes out of milling the logs, and it's a waste product. The only problem with the lignin sulfate itself, we used to use a lot of it in gravel roads treatment, but it's gotten expensive. And the reason it's expensive is that they use a lot of it in the production of cardboard or other types of wood types of products, to glue them back together. But the lignin sulfate is a very good glue for a gravel roadway or unpaved roadway. The only problem is if you use just straight lignin sulfate, you've got to take and mix it in with your gravel. Have some water in it, mix it in. I've got some pictures I'll show you a little bit later on of a lignin sulfate project where we mixed it in with the gravel road material, then laid the gravel road material out, compacted it back down, and it glued it back together. It gets really sticky. Okay.
Bruce, I've got a
The
couple
tall
questions.
oils.
Sorry. Would you have time for
Yes,
a
go
couple
ahead.
questions real quick? Okay. One question
Sure.
is, and this is a more recent question, and then I'll read you the other one that came in probably about 10 minutes ago. The first one is, our local agencies in Michigan have not had good results with sodium chloride, mainly due to it needing a much higher relative humidity to actually start absorbing water. Does it work in the western states?
I only have two different agencies in the western states that use the sodium chloride, because of the same problem. Here in the western states, our humidities, when we talk about humidity, we're talking about, 8, 9, maybe 10% during the summer. And so we're really low humidities compared to Michigan. And so the sodium chloride, I really don't recommend it as a stabilizer because of that issue. Generally, what we'll find is if we use a mag chloride or a calcium chloride, we'll actually see it pick up some of that moisture in the nighttime cool air, because our humidity will come up a little bit and it can gather some of that moisture. So I try and steer people away from the sodium chloride for that reason.
Okay, and then the next question, this individual wanted to know, what about the salts weakening the road base?
Generally speaking, and this goes back to something I should have mentioned it a little bit later on, or a little bit earlier on, is that before you do any type of stabilization, if you have some weak subgrade soils, or if you have a subgrade soil that has, say you have a spring under it, a area that water comes up into it, you need to deal with that weak subgrade soil or that moisture before you ever think about stabilization. Because, especially if you're using some of the salts, if that roadway gets soft, well, any of these stabilizers, if the subgrade underneath that stabilizer gets soft, the road's going to get soft and it's going to break up and you're going to have problems with it. Now with the salts, if you have moisture that's down underneath of it and that moisture is going to be present all the time, it can pull that salt down out of your surface material, and that's not what you want. And so try and make sure your ditches are clean, make sure your subgrade material is as dry as possible, in as good a shape as possible, because otherwise it creates more maintenance work. Good questions. Good questions. I appreciate them very much. Keep them coming in.
You got time for one more?
Anything else? Any
Yep.
other?
Here
Sure.
we go. Someone wants to know, how many gallons per mile for calcium chloride would you recommend?
For calcium chloride, as a pelletized form, generally speaking, most agencies will use a pelletized type of form of calcium chloride. And I'm trying to remember.
And we can always send
I
that
can't
out
remember right
afterwards,
off.
too. Yeah.
Yeah, let me get back with you on that question. I'll because I can't really remember exactly how many pounds per square yard that they're looking at as far as the calcium chloride. It's not very high, but by the same token, I'd rather give you the best number possible for you.
Okay. That's all the questions we had for right now.
Okay. So, you take a look at the tall oils. It's also out of the timber industry, and they work out fairly well. The new one that we've got is the molasses or sugar beet industry. They're taking and marketing their waste product, both for winter maintenance as well as dust stabilization or road stabilization, and it works. But by the same token, some of the issues you'll find is that one is going to smell sweet like molasses. Your roadway will, but by the same token, it works really well. One of the other ones that you'll find a lot in Ohio, in the central part of the United States, is some of the animal fats or vegetable oils. Some of the corn oils, the soy oil, the canola oil, and they all work really well. The only thing with the non-petroleum types of products, all those non-petroleum types of products have to be mixed into your material. And so what some of the companies are doing is they're taking lignin sulfate or your tall oil and mixing it with magnesium chloride, because then the magnesium chloride helps to take and transport it down into the material a little bit better, and also gives them the reworking ability, because the lignin sulfate, the tall oils, all those types of products, when they dry in your road surface, they get hard. But as soon as you come with a grader and start cutting that surface again to reshape it, you're going to have to add some water, mix it back up, and recompact it to get it to take and be able to work relatively well. And a lot of times it doesn't adhere back together as well as it did originally. The electrochemicals. These are your enzymes, your ionics, and your sulfonated oils. These are the specialized types of products, and they are very specialized. Generally speaking, with the sulfonated oils or the enzymes, you've got to take a look at the clay particles themselves and see how they're structured. What is their ionic charge? What type of chemical is going to take and change that ionic charge? Let me go back for just a second, because I forgot. Under the organics, there's a couple of organics that aren't in my list. They're used pretty extensively in some of the parts of the country. Lime and cement. Lime, especially if you have a lot of clay types of products, you might see an agency use a lime or a cement in their subgrade to take and try and stabilize that clay type of product. But like a petroleum type of product, once it's dried, you're not able to take and regrade it or deal with the surface. And if it starts breaking up like the petroleum type of product, you've got to fix it with the same type of product that you originally did. So on the petroleum types of products, they'll generally take and patch it with hot mix or cold mix. On a cement treated type of roadway, you've got to take and chip it out and remix it together and put in some more cement and more or less patch it. So it creates some problems in your roadways. But those electrochemical types of products. They need to be designed. They need to be taken, and the agency or the organization that are using those types of products, they need to take and do some research on your material to make sure that that characteristics of that clay particle is going to work with that enzyme, that ionic, or that sulfonated oil. So take, for example, that work that we did in Arkansas with the U.S. Forest Service. He decided that he wanted to take and try and build a unpaved roadway that would last for a number of years. And so he found that he could take a shell type of stone, which is a soft stone, combine it with a lava rock, and which is a hard stone, and then as those two stones worked together and moved, the lava rock would break the shell down so that it would continue to create a binder to hold that road together. And then they treated that whole roadway with an enzyme that was specifically designed for that roadway. And like I said, he got 30 years out of it. That was pretty amazing. Generally speaking, when you have a vendor come into your shop and say, hey, I've got a chemical that's going to take and work wonders on your gravel roadways, it's going to help you a ton, you need to find out which of these families it's part of. And if it's an enzyme, an ionic, or a sulfonated oil, you may need to take and have some additional testing and also some additional certification on those types of products. It needs to be engineered. It's not as common of a product, and so it's a little more difficult to work with. And generally speaking, what they do is they'll come in and they'll grind up the roadway and they'll mix it, the enzyme or the ionic or sulfonated oil into it, with water. Then you lay it back down and you compact it. And if it works right, it gets really good and hard. Works out really wonderful. But if it doesn't, you can have some real problems with it. So if you're looking at any of those electro type of chemicals, I recommend that you get some additional engineering, and also get a lot more references on the type of product that you're taking a look at using. Now, over the years, we've seen a lot of the synthetic polymer emulsions, and it's just like the picture shows you. The Elmer's glue or the paint, the polymerized types of paints. The paint and the glue industry is actually where these types of chemicals originally came out of. There are the polymerized vinyl type of product, or the acrylic type of product that they're mixing in paints and different types of products. They've now taken and moved them into a road type of application. Generally speaking, what you'll find with the polyvinyl acetate or the vinyl acrylic, or a combination of that type of a product, is they're wanting to glue your roadway together. And so once you take and you install this type of product, you generally cannot rework it. Especially, well, when it dries, it's going to get hard, but it's going to take and hold together. So in those types of situations, that's what they're looking at with these synthetic polymerized emulsions, is taking and being able to try to glue. And you'll see a lot of those types of applications in roadways that have a real high sand content, a real low clay content. They prefer not to deal with the clay, but they'll try and glue that material together. And so you're going to have to take and mix up the roadway and fluff it up, and then you apply the synthetic polymer emulsion. You mix it all up, you grade it back out, you lay it back down, you compact it, you let it dry, and it gets hard. So that's the 5 primary families of stabilizers. Now, like I said, in some organizations will take and like up in northern Idaho where they use a lot of basalt, they crush the basalt. It doesn't have a lot of clay, a lot of binder in it. It's very interesting that basalt, lava rock, as it breaks down over the eons, it becomes clay. But as a rock, it doesn't have any clay in it. So a lot of times we'll ship clay in the form of bentonite, dried bentonite. Up in central part of Idaho, they ship in truckloads of dried bentonite and then mix it into their belt feed as they're coming out, if the rock is coming out of the crusher, to increase their PI and be able to hold their material down. A lot of those organizations that I've worked with over the years are currently now using the bentonite. They mix the bentonite in, and then once they lay the gravel back down on the roadway, they actually treat it with a mag chloride to try to make sure the bentonite stays in that roadway. It doesn't turn into a powder and get blown off that roadway. So that's another type of treatment that you have available for you. So when you're taking a look at these different types of chemicals, you need to decide on your roadway, okay, I want to take and use a chemical. Are you going to want that chemical to be able to be, or that road surface to be able to be reworked? Are you wanting that roadway to take and have the appearance of maybe a paved roadway? I've seen it done, or a number of agencies go through and do what's called an otter seal, or I call them a BST, which is a double seal, and it's just pretty much a seal coat, and then you seal coat over the top of it, trying to develop a little bit of structure and armor that surface of that roadway. The only problem is once you do that otter seal, or do you do that double seal, every time if you develop any holes, any potholes, you got to come in and patch them just like you would a paved roadway. And you also then have to take and continue doing your seal coats, or like they did in South Dakota, where they came in and took some of those types of roadways and reground the road material back up, mixing it into the subgrade a little bit, and then made them into a gravel road again. But you've got to take and make a decision on what type of properties do you want that roadway to have. So if you want a roadway that you're going to take, and let's say you're in an area that has a lot of oil production, like you do, I think, over in the eastern part of the state, you may be able to get access to some of the petroleum types of products fairly easily, and they will work really well to take and armor that surface and keep that dust down and keep it from being able to fly away. Over in the western part of the state, you may need to take and where your petroleum types of products may be getting up a little higher in cost, and you may have more access to, say, some of the salts, or maybe actually there in Ohio, they have a lot of interest, or a lot of production of the corn oils, the canola oils, the peanut oils, those types of oils. You need to look at those costs and decide what type of product you want to use, and then make sure you install it correctly. Make sure you have a comprehensive safety data sheet for it, and that you have the proper design, and that the design on how to install it, what is your application rate, how much material are you going to use, has been tested, and they can prove that it works. because I've seen it happen a couple of times where we have somebody come and say, hey, I've got a product that works wonderful, and then you install it and it doesn't work very well at all. And so you need to be kind of cautious of what type of stabilizers, the salts, the asphalts, or the petroleum products, and also the other organics. Most of them have been tested pretty thoroughly. And so the other option you have is to check your state specifications. Also check other local agencies in your area that use the same type of product. And so you can take a look at what the mix design is. How well did it work out? How long did it hold up? So when you look at it, asphalt emulsions, you can, generally speaking, what I see on some of the SS1, the CRS2s, the high float types of emulsions. Well, generally speaking, with the SS1s, the CRS2Rs, the CRS2Ps, generally they're sprayed on. And then hopefully they penetrate a little bit of the surface, but they create that top surface. And then a lot of times the agency will either come in and put chips on top of it or sand on top of it to blot it and have it dry and cure. Some of the high floats, some of the other asphalts, you may mix it together with the surface material, regrade it out, compact it, and then let it cure. Portland cement, generally, Portland cement is always mixed, and you have to add moisture to it. Then you meter out the cement, you add moisture to it, or you add the moisture by a slime. You've got to mix it into the material. And generally speaking, if you get over about 8% by weight of cement, it will crack just like concrete. So you want to make sure that you're running and you have the right amount of cement into your aggregate so you don't get the cracking, but yet it still holds it together. So, what I've found over the years in a lot of different projects with the Portland cement type of application, about less than 8%. Normally you're running about 5, maybe 6%. Lime, I don't like lime. I've had one project with lime and it was a mess. Matter of fact, we ended up having to shut down the job a couple of different times because of safety issues. It does work well, but it works well with a real high clay content. And it generally has to be mixed as a slurry. It's maybe metered out onto the roadway as a wet product, and then more water is added and it's mixed in, and it performs about like cement, Portland cement. The remaining liquid treatments are generally sprayed or mixed. The salts, a lot of times you can spray it on the roadway and let it penetrate the roadway. And like I said, it'll penetrate down as deep as the moisture. One caution I would take and give you with salts is that if you have high air temperatures and low humidities, and your surface temperature starts getting up around 110, you may not want to shoot your salt, your magnesium chloride or calcium chloride on your roadway, because it's going to, what ends up taking place is that it loses its moisture too fast, and it doesn't allow the salt to penetrate your roadway very well. So you may want to do that type of treatment if you're expecting some real warm weather early in the morning, or maybe late in the evening after the roadway cools off a little bit. Generally speaking, on the dry treatments, most of the dry treatments, what you'll do is you'll take and mix the material into the surface and with some water, and then let the material cure. The biggest thing that I'll tell you on all these treatments, don't misuse them. If you're expecting rain, rain will cause a problem with each one of these treatments, especially if you get a heavy rain. It may wash it right off the roadway and cause you problems in your ditch line. So you need to take and make sure you're doing this during good weather and that you follow the proper procedure for each one of these types of treatments. And your suppliers, you've got some good suppliers in your areas of some of these chemicals. If you're interested in the chemicals, you can also talk to, of course, your DOT, as well as your fellow counties and local jurisdictions in your area. Do we have any questions so far, Victoria?
Yes, we have a couple of them. One question, the individual wants to know, have you had any experience with life-fed technologies? It's LITHIFED.
That's an easy one. No, I have not.
Okay. The next question is, can you elaborate on treatment that you mentioned at the start that did not work for the road on the cover of the Unpaved Road Dust Management Handbook?
Yes, it was actually a company out of South Africa that was trying to market a sulfonated oil. You end up, when you're dealing with some of these companies, they'll tell you that their product is a proprietary product, but by the same token, and that's what they ended up telling us, but we ended up getting a sample of it and testing it. There was a sulfonated oil, but the design he was using for the product, he had some mistakes in his design, and it caused the product to fail. He's using it in the wrong place with the wrong type of clay, and so we ended up having a lot of problems with it. But it was a sulfonated oil, which, like I said, those enzymes, those sulfonated oils, those specialized type of products, they have to be very extensively designed, so you have to be very careful with them. And hopefully that answered your question. But we did end up taking and removing a lot of that material and then rebuilding that roadway, and it works really well with its mag chloride treatment. So here, of course, here's an application. This is actually a mag chloride, but I've seen calcium chloride, sodium chloride shot this way. I've also seen a couple of organizations that will come in and do an asphalt treatment using a distributor. In this application, we actually had compacted that roadway somewhat. We left it a little bit open so we could spray it and shoot it at about a quarter of a gallon per square yard of the magnesium chloride, and would not allow that mag chloride to run off the road into the ditch. We kept it up pretty much in the roadway. Then after we did the treatment, then we actually came back in with a roller again and recompacted the material and made sure it's compacted really well. And then took the roller out and washed it. Got the magnesium chloride off of that roller. Generally speaking, if I actually had fully compacted this roadway, we would have been shooting probably about a eighth of a gallon per square yard. And then shot it in 4 shots instead of 2 shots to get it up to that half gallon per square yard. This is a treatment that we had up in the northern Idaho area. This is with the Forest Service. This is a lignin sulfate application. And you can see that they've cut the surface of the roadway and created berms on it because they had quite a bit of grade here, and they're really concerned about the material running off the side of the roadway. So they're trying to contain that lignin sulfate as they're applying it. And then in the next slide, they're coming back through, and you can see that this was an open road, but by the same token, they're taking and remixing that lignin sulfate in with that gravel road material and then laying it back down, and then coming back in and I think no, I thought I had the picture of them compacting it. They came back in and compacted the material down, and it worked out really well. But it takes a little bit more time, a little bit more work to get it all laid out, and that's lignin sulfate. Now, a lot of agencies that I've worked with over the last couple of years, I've got a number of different agencies that have actually came in and bought this grinder. This is a cat grinder. There's a couple of different brands of them. You can actually take and hook a truck up with your mag chloride or your lignin sulfate or your other type of chemical, and they'll actually grind it and mix it down into your roadway. Or if you're doing a crabs type of a recycled asphalt base type of product, you can actually have a lime slurry or a cement slurry fed through that same hose into that grinding operation. So you can mix it into your material. Then back in the back part of it, you can see the grader coming up behind him, grading his material, trying to shape the roadway, and then of course had compaction on it on behind it. This is actually the belt feed that we use up in the central part of the state of Idaho, where it's coming right off of the crushing unit out of a quarry source, and that's the bentonite that they have hauled in railroad cars, and then they meter it out into their aggregate and stack it into their pile. And generally speaking, most of the quarries are owned by 4 or 5 different jurisdictions, and so they all can take and use the material out of that pile. But the bentonite is just to take and supplement, provide them with that binder for that gravel road material. So making sure that whatever type of application you're going to take and use, make sure that you have some quality control, make sure you're applying it correctly, making sure that if you're supposed to mix it, that you're getting the right mixture or that you have the right moisture in the roadway. Make sure that you have good weather when you're going to be doing this type of activity. Like I've said, if you have rain predicted or if you're anticipating a large storm coming in, you may want to put it off until after it's done. And then every one of these techniques, compaction is critical. Making sure you have a good subgrade and then also compacting your surface material. Make sure it's compacted solidly and that you've taken and mixed the material sufficiently. Joe Weiss is actually a engineer that I work with a lot up in northern Idaho. He now retired. He retired actually in 2011, but he's the one that owns the managed most of the roads up in Lakes Highway District, and he found that he could actually save his jurisdiction money by taking and using chemicals, magnesium chloride primarily, reduce the amount of costs that he had as far as his road segments in both complaints as well as having to go back out and continually regrading. That Ohio Match Road, before he started dealing with it and treating that roadway, he was grading that roadway once a week. And that's a lot of maintenance. And so by going through the treatment, he was able to reduce his maintenance costs to twice a year doing a full treatment on that. So do we have, and that's pretty much all I have for today. I really appreciate Victoria allowing me to come in and do this program, as well as, like we've said, I prefer to do it in person, but by the same token, this has worked out really well. I appreciate having me come in, and also all of you that attended this program. It's a lot more enjoyable being able to have people that'll sit in, ask questions, and provide information.
Absolutely, Bruce, but we appreciate you doing it in this format. So, and the fact that you made yourself available to provide the training. Hopefully, moving forward, we'll be able to actually bring you back in person and maybe even do a mixed version where we have you in the classroom in the morning, out in the field in the afternoon. So we're getting rave reviews in the question box. And I want to thank everybody for joining us for this series. And Bruce, thank you. And I hope you enjoy the rest of your day. And everybody, please stay safe. And we hope to see you again on a future LTAP webinar. Thanks.
I agree with that completely. And thanks again.
Uh-huh.